Our objective for this project are to identify the best fitting function that makes prediction of the daily users metrics for data.government.my in Malaysia. Second, to construct the least squares linear and quadratic from the data. And the last one, to examine the sum of squares error for every least square function that we use. Official Malaysian government website that we choose by us is Ministry of Digital. About 20 data points had been selected from the website that focus on the daily usage metric for data.government.my. From the data, the independent variable that we choose is Open API hits. Meanwhile, the dependent variable is downloads. We choose both variables because we can know how many times the users used to visit and download the data that we provided by data.government.my. The users metric for data.government.my dataset provides a detailed daily record of how Malaysia's official open data portal is being accessed and interacted with by users. It captures key performance indicators like open API hits and dataset downloads. Daily user metrics for data.government.my show the transactional records that be produced by a web analytics tool which monitor the user's interactions across the data.government.my platform in real time.
This is the data for our group project where OpenAPI hits as an independent variable x and downloads as a dependent variable y.
First, we look for the least square linear function. The figure shows all the 20 datasets that we choose by us that we plot in a graph. For x-axis is Open API hits and y-axis is download. Next, let's do a calculation to find the equation for a straight line. To find the equation for a straight line, we need to find the total of A and B. We know that the total of n is 20 and the sum of x is 7,153. Meanwhile, the sum of x squared is 3,170,730. For the sum of y, we get 7,394, and lastly for the sum of xy, we get 2,565,309. After doing all the calculation, we get A is 1.585 and B is 353.06. So we substitute A and B into the equation of this straight line. We get y equals to 1.585x plus 353.06. Lastly, we also do a calculation for sum of error square. We get 8,423,130.959.
Next, let's move to the least square quadratic function. This graph shows the relationship between OpenAPI hits and downloads. Each red plot represents the number of downloads for a certain number of API hits on a day. The blue curved line is a trend line that shows the overall pattern of the data. From the graph, when OpenAPI hits are low, the number of downloads is also low. As API hits increase, downloads increase gradually. Downloads reach their highest level at a medium number of API hits. After that point, when API hits become very high, the number of downloads start to decrease. The equation of the curve is f of x equal to a0 plus a1x plus a2x squared. Before we calculate the sum of the square error, we need to find the expected equation by determining the respective value. The value of sum of x is 7183. The sum of x squared is 3170713. The sum of x cubed is 164,715,0949. The sum of x to the power of 4 is 9.424897 times 10 to the power of 11. The sum of y is 7394. The sum of xy is 2565309. And the sum of x squared y is 1066209507. Then we substitute the value into the normal equation of metric to find the value of A0, A1 and A2 by using determinant. Lastly, we got A0 equal to 111.21, A1 equal to 67.544 and A2 equal to negative 3.1409. Therefore, the expected equation is fx equal to negative 3.1409x squared plus 67.544x plus 111.21. After we find the expected equation, now we can find the sum of squared error. We substitute the value of x into the equation and calculate the error by subtracting y and calculated y. Then, we square the error to get the error square. Lastly, the sum of square error is 861,77282,464,76.66. In summary, the calculation demonstrates that the least square of a linear function fit the data from an official Malaysian government website significantly better than the least square quadratic function. It is because the linear function curve has a smaller sum of square error SSE than the quadratic function.